Assalamu alaikum guys, hope you're doing fine. In today's video we have something very interesting to look forward to, and that is dynamic memory allocation. So without further ado, let's get going. So what is dynamic memory allocation? We have seen that in our program, whatever we declare, whatever variables we declare, the space needed by that is read beforehand by our operating system. But when it comes to dynamic memory allocation, the memory is dynamically allocated on runtime. So if a statement encounters any instruction that it's executing at the current time, and it says that need this much space in the memory, so that is created on runtime. So in short, when it comes to that particular statement, at that particular statement, at that time, space is made in our memory, and that is dynamic memory allocation. So without further ado, let's get going. If I want, why do we need a dynamic memory allocation? The best usage of it is in arrays. So you see, when we don't know how many people are going to be there, say if I'm making a program for a garage, we don't know how many cars at what time appear. So I need to know the accurate. If I were to use static memory, I mean using primitive arrays, I would have known that number, and I would have made an array which is large enough to hold the size of maximum number of cars that can come into garage. But that is not an efficient solution. An efficient solution is the exact size required by that by those cars is provided at that time, so that your program doesn't occupy the space that it does not necessarily needs. So we are going to use pointers in this video, so make sure that you have gone through the last videos in which I have done pointers, and the two operators that we need is address operator and dereference operator. In dynamic memory allocation, the keyword that we use is new. So here is it, new. Then if I wanted to declare an integer, so understand the difference. If I were creating int a is equal to 5, the space hasn't been allocated yet. If my program is compiled, at compile time, when my program is building, so space will be allocated for this integer, means 4 bytes will be allocated for this integer on compile time, not on runtime. So if I were using new int a is equal to 5, now it's interesting. So now new integer will be created. Okay, so the standard method is, first you create a pointer, int pointer ptr is equal to, now that you have created a pointer, you new a memory, new int and then statement terminator. Understood? I'll get to the syntax now. This was since our static memory has a name, okay, this name is a, but when it comes to dynamic memory, there is no, actually the dynamic memory is located on our heap memory, not on our stack memory, which handles all of our static memories. So this process that now we're going to do is going to be on heap section of our RAM. So here we are, integer ptr. Since this new keyword is used to allocate memory in our RAM, it returns an address that has available storage for the type that we want to be allocated, size of type that we want to be allocated on that particular space. So that not particular space, any space. So new will give me an address. That address will be stored in the ptr pointer and then PTR pointer will start to point towards that particular space that has been allocated on runtime. So if I compile this program on line 14, if my execution is currently on line 14, integer a would have been already declared on compile time. So my operating system knows that now I'm going to execute this program, so I need an integer that should be ready before I use it. But when it comes to dynamic memory, when it comes to execution comes at line 15, now it reads, oh, it's a new keyword, so on that particular runtime instant, memory will be allocated and given, assigned to PTR pointer, and then PTR pointer starts to point at this memory. So this was the whole story. Now on to the syntax. Since we are given an address, we cannot name it because we have granted an address. So an address can only be stored in a pointer. So the name of that pointer will be used at that as a name of that memory. So a pointer will be pointer. All the basic rules of pointer are the same. So now if I wanted to change the literal stored in A, I would just write A is equal to 6 and A's value will be changed. But when I want to change the memory pointed by PTR, the method I am going to adopt is PTR. Now this is address. I want to derefer this address so that I can change the memory on this address. I'm going to write dereference operator behind this pointer. So whenever it comes a dereference operator behind as a prefix of an address, which is PTR, it stores an address actually. So we are given access to this integer that is newly created on the runtime. Now we want to give it the value. So it's simple, you just put in the value in that address. I hope this wasn't difficult as I sounded it would be. So now, review. If I want to create an integer, I'll just name it add is equal to 4. So an integer has been formed, and this is on compile time. So if I wanted to create an integer on runtime, I would declare a pointer PTR or anything. Say num is a pointer, and I'm going to give it an address which should be new. So new integer. And remember this: an integer pointer can only hold the address of an integer. If I were to do character, this is wrong. As it says, cannot initialize a variable of type integer pointer with an R value, right value of a type character pointer. So this can't happen. It should be integer. This is it. Now if I want to insert value inside, I am going to do dereference operator num, which holds the address, which has to be dereferred in order to insert a value. So here I am. If I don't put a dereference operator, it's more likely I'm trying to change that address. I'm trying to so it says assigning to integer pointer from incompatible type of int. I cannot assign address. Now compiler thinks that 45 is an address and I'm trying to store it in number because number is a pointer. I cannot store 45. I cannot just say, okay, empty address 45 for me. Maybe a part of operating system is stored there. Maybe your start menu is stored on 45 address. So you are likely say that empty the address 45. I want to store my integer value on it. So you want to empty your start menu and enter your address. So this was a rough example. I hope you tolerated that. So we need to derefer the address which is returned by this new keyword and then insert the value inside. So this is more like an appropriate way to do it. But the thing that we don't require a pointer for this normal task. We do pointers when we have to declare a dynamic array. That means you don't know how many students would take admission this time in the university, so it's more likely your program comes to know how many students have been admitted to the university on run time. So your program's already running and it's asking for a size, so you give it a size. Okay, 500 students have admitted this time, so your program's already running and user enter 500 and an array of 500 has been declared. So this type of programming has been is done on dynamic memory allocation on heap memory, not on stack memory. So let's create an array of 500 integers. So int, we need a pointer obviously to point to, so ptr, or I can say students. So this is my students pointer and I want to assign it 500 integers consecutively. So new int, and similar to our previous method, the way we declared arrays. So int 500, just pass the size you want, and now dynamically your array will be formed. Not yet will succeed right now. The array has been formed. I presume the program is still running. So now the memory has been created, not on compile time actually. So if I were to stop the program to give you a demo, so I'll just create int a, and then I'll say cout std cout, enter the number std endl, and then std cin a, and then std cout. Now the memory will create. So if I run this program, so the array hasn't been declared yet. Okay, array hasn't been declared yet. I enter 12, not yet, now. So when as soon as this part has been output, this will create now memory will create. So after the output process has been done, right next moment 500 integers on consecutive will be declared on our heap memory. So this is dynamic memory allocation. You can now declare your character pointer names is equal to new character, and say 12. So you have 12 characters inside, or you can use this thing as a string as well. So if I were to input anything inside this, I could have used it as my input, because character arrays are more likely a string, because in string class we learned how to declare string in our previous lesson. So string is similar to this character array. So they created string by using the same method. But the default size is 8 in string. So here we are trying to input an address which is at names, and see what happens. Let's run the program. Build failed. Expected. Yeah, I put it accidentally while the execution of the program. Will succeed. Enter the number, which is 12 or 1. Now the memory will create, and memory of 500 integers has been created for students. Now it's asking for it's on line 20 actually, waiting for my input. So I can input as a string Abu Bakr. So it has input like Abu Bakr. One new thing though, it can't read white space. It will read the string until the white space, unlike string. So if I were to say, not here, here, 12, Abu Bakr Asif. Oh, sorry. So it would have read Abu Bakr only, not Asif, because it's the way cin operator has been designed. So if I were to say output cout name and see what happens. Build failed. User undeclared identifier. Oh, it's names, not name. So names. Now, again for Abu Bakr. So it has only read one character. Forgot to tell you this. Now we'll try to build a program in which we are going to take input from the user and declare the array. So int size, and the reason it has given only a as output because it's an character array, and I have set it to give me whatever is stored on names address. So name is actually I'll just draw this here. So consider this is our array in memory that stores a, b, u, a white space. I'll just put an underscore here as a white space, and then it stores b, a, k, a, r. So the address that is stored in the pointer when it comes to array is always the address of the first index, and in here I'm saying it, show me what is stored at the address that is stored in names, derefer that object and show me what's on it. So it has gone, so pointer always point to the first element of the array. So it showed me a. Okay, so a has been output. This was an important concept to understand. It automatically came into sight, otherwise I would have ignored it, totally forgot. Now, if I were to create an array on runtime by, like I said, a program asks how many students have been admitted to the university this time, and you give it the number. So something similar to that. So number of students. The reason I'm teaching you is that we'll be creating classes in the next video in which we'll be needing dynamic memory. We cannot just create an integer array on static memory whenever object is created. So sometimes we do not need to fill that. Say garage, there are days that no vehicle enters on garage. So what? We are going to keep those slots filled? No. In that case, we are not going to assign any memory to that, so that program is made efficient as it should be. So number of students, then I have integer pointer students, ptr is equal to, sorry, I should have, so now std cout, enter number of students, and then you are going to input how many number of students have been admitted to the university this time, so number of students as an input, and then you're going to create a memory int ptr is equal to new int, and in this we are going to send number of students as our number of students. So this will be created, and if you wanted to initialize all these values, so you are going to need a for loop int I is equal to 0, since the starting index of an array is equal to 0, and we know that the loop will go on till number of students, the maximum size, number of students, and then on each iteration we want to increment I, and then we want to take input in our cn individual students, so integer ptr I, right? But before we do, we want to give ourselves a signal that now we have entered in the loop. We are going to enter in a loop, so std cout, enter the names. Oh my goodness. So a huge mistake. Since number of students are going to be recognized by number of students variable, so when I want to enter the names should be string. So when I want to enter string, I want to have string variable inside, so std string, and this should also be string, new string. So you can also, in our previous video, we created a structure, a class of vehicle. So you can create a dynamic memory of your vehicle too, just like I did with string. So you can do it. Cin, cout names, should be std string. Std string. Do you see error anywhere? I don't. And then we want to see whether they have been input correctly. Cout std endl, but after it we want to use the same for loop, same design. Just make it's more clear when we talk the programming. So I need for loop that is going to start from 0 and that is going to run until number of number of students, and on each iteration I want I to be incremented, and then I want to see out the students which are on indexes variable I. So when I is 0, 0th indexes are going to output whatever inside it, endl, and also stream insertion operator here. So in the end, since this line is disturbing, programming ended with code 0, we wanted to print on the next line. So I want std cout. So there is an alternate method to do that also. You just need to have \n, and if you want your program to make a sound when it turns off, whenever it asks for input, that's going to be nice. So we want to, whenever it asks for input, we wanted to create a sound. So now it's waiting for the input. std cout, I suppose that's \a for alarm. That's it. Let's run the program and see what happens. So, how many students did enter your university this time? Oh, the university was going through a hard time, so students were only 4. Enter names. Why didn't it make a sound? It should have. First was Abu Bakr. No sound. Well, I have to look into this. Abu Bakr, then it was Ahmed, then it was Mohsen, then it was Shabazz. These three students. But why didn't it make a sound? Need to look into it. So we'll look into this later, but this is the main idea of the code. Till then, keep smiling, stay smiling, seek smiles and spread smiles, and subscribe to the channel. If you don't understand anything in today's lecture, go ahead and comment it under the video, or you can email me at double8632632632@gmail.com and keep on giving your suggestions that how should I make the videos better and better, because I don't want you to suffer when I start Swift or HTML or CSS or JavaScript. There is much to come. This channel is going to throw up everything that I'm going to learn about computers. So it's about free, and I hope that soon enough we will start our journey on creating a better world with better apps. Till then, Allah Hafiz.